Hi everyone, welcome to part 2 of solving absolute value functions. In this example, you'll notice that you have two absolute value expressions on each side. And so what you need to do is basically rewrite it with no absolute value lines there. And then you're going to do it, you'll solve it, and then you'll do it again where one side will be negative. And so for me, I like to pick the side with the least amount of work to do for the negative, so I'll just make that side negative I. And so in the previous video, I gave you a problem where it's like absolute value of like x plus 2 equals 4, and then you set it equal to, so then you'd write x plus 2 equals 4 and x plus 2 equals negative 4. See how you made one side positive and one side negative? So you're really just repeating that same kind of thing here. So, all right, I'm going to just get right back to solving this. So I'm going to minus 2i to the other side to get my i's all on one side. And I'll do that down here as well. And so I'm going to get I minus 2i is negative I equals negative 3. And this is negative I minus 2i is negative 3i equals negative 3. Okay, so looking back at the top, if negative I equals negative 3, then positive I equals positive 3. And then down here at the bottom, if negative 3i equals negative 3, I can divide both sides by negative 3. And I can get I equals 1. Alright, and that'll wrap it up for that one. This one, I'll do the same approach. I'll say 5j equals 3j plus 1. And then down here, I'll go 5j equals 3j plus 1. And then I'll make a side negative, and I'll just make that a negative 5j. So, I need to get all my j's on one side, so I can minus 3j. Alright, and that'll give me 2j equals 1. And then I can divide by 2. And I get j equals 1 over 2. So on this one, I'll minus 3j over. And now I'll have a negative 8j equals 1. And then when I divide, dividing by negative 8, j equals negative 1 over 8. Alright, so that's it for that one. Let's keep moving on. So this one, negative 3k equals k. If you think about it, the only answer for this can be 0. And if you're like, what, why? Well, think about it. I'm going negative 3 times a number equals that same number I'm plugging in. So negative 3 times 0 would equal 0, and plugging in 0 here, well, that's 0. So mathematically, or algebraically, I guess, I don't know. How am I going to show my work on this? I'll go one side negative, one side positive. So negative 3k equals k, negative 3k equals negative k. And there. All right. So minus k over, add k over now. K. I do not write k's that well. So minus 4k equals 0. Negative 2k equals 0. If you divide 0, if 0 divided by anything makes 0, so k equals 0 on both times. Alright, let's move on. So on this one, I have numbers on the outside of both absolute value ones. So I can clean it up a bit if I multiply 2 to the outside of each of them, of each side, I should say. And that'll get rid of that fraction. Okay, so I'll have 8 absolute value of L equals absolute value of 6L minus 2. All right, so now I'm going to make my two equations. I'll say 8L equals 6L minus 2. And then I'll do it again with 8 L equals 6L minus 2, and then I'll make it negative right there. So, get all your L's on one side. Get minus 6L, minus 6L. And then I can do the same thing down here. So I get negative 14L equals negative 2. I get 2L equals negative 2. And I get L equals negative 1. All right, this one, I'll divide both sides by negative 14. L equals 1 over 7. All right, that wraps it up for that one. This next example is kind of a special example, special problem, I should say. Here you have 3n plus 5. That's like a linear equation. And 1/2 times the absolute value of 3 plus n, that's going to make a v. A linear equation is going to make a diagonal line. And so sometimes when you have a diagonal line, yeah, they can intersect 2 times. But other times when you have a diagonal line, sometimes they only intersect once. Okay? And so why am I bringing this up? Well, think about it like this. No matter what I plug in to an absolute value, it's going to output a positive number. So if I plug in a negative number here for n, I can still get a positive number. But if I plug in a negative value here for n, it'll stay negative on that side. So I'm going to end up getting an extraneous solution, and I'll show you what I'm talking about right now. So for starters, I don't like having this fraction here, so I'm going to multiply both sides by 2. And so if you're multiplying both sides by 2 and there's more than one thing on the other side, use parentheses so you remember to distribute. So I'm going to say 6n plus 10 equals 3 plus n. All right? And then I can say minus n. All right? And then at the same time, I can minus 10 to the other side. I'm just trying to make my work nice and compact here. See, I'm canceling one thing on each side. I get 5n here, and because I canceled out the 10, now I have negative 7 over there. So I can divide by 5, and I get n equals negative 7 over 5. If you'd like to, you can get that in the decimal. It's negative 1.4. But really, it doesn't matter to me. All right, can you tell that's a 1.4? I hope so. So, now I've done it that way. So, let's see here. Let's cover the negative end. The negative end, I got to make one side negative. So I can choose, I'll start at the 6n plus 10, because why bother multiplying 2 to the other side? It's understood that I'll need to do that. So 6n plus 10 equals, and it was 3 plus n. All right, but one side's got to be negative. And on the other examples, I just had one term. So I have 2 terms on both of these. I need to pick one side to be negative, and just use parentheses so you remember to distribute. And it doesn't matter the side, so I just chose the right side. So this is going to say 6n plus 10 equals negative 3 minus n. All right? And so now I can add n over, and then minus 10 over like I did before. So that cancels n's on that side, that cancels 10's on that side. So I have 7n equals negative 13. And so now when I divide by 7, I'm going to get n equals negative 13 over 7. Or that's about negative 1.86 if you want to round it to a decimal. Now, one of these answers does not work because of the speech I made at the beginning. All right. Now, why doesn't it work? So what I want to do is I want to show you the graph of 3n plus 5 and then the graph of 1/2 times the absolute value of 3 plus n. Okay, so here's a screen grab from my calculator, and I graphed 1/2 times the absolute value of 3 plus x, because you can't graph any other letter than x. And I graphed that on one line, and then on another line, I graphed 3x plus 5. That F10, F9 stuff, ignore that. That's just, if you notice, I had a bunch of stuff typed in into other pages. But you see they only intersect once, and that's at negative 1.4. That was the solution we got right there. Now, there is nothing showing negative 1.86. We just look at the x-coordinate. That y-coordinate's confusing you. That's just what would happen if you plugged in negative 1.4. You'd get 0.8. So, it is not intersecting at negative 1.86 on the x-axis. All right? So why is that though? It shows up, I mean, it's not showing up in the graph, that's one thing, but this is algebra, so there should be an algebraic, explanation for this. So what I'm going to do is I'm going to plug in that answer that didn't work, that extraneous solution. So 3, I want to use the original, 3n plus 5. So I'll say 3 times negative 13 over 7 plus 5 comes out to negative 4 over 7. And so when I plug it into the right side of the equation, 1/2 times the absolute value of 3 plus n, it's going to get 1/2 times the absolute value of negative 8 over 7, which means it's going to do 1/2 of 8 over 7 as a positive now, because we did the absolute value of negative 8 over 7. So that's going to equal a positive 4 over 7. So you see I get positive 4 over 7 and negative 4 over 7. Well, those just don't match up, okay? So that's what's going on. It's because since you can plug things in and make it positive from the absolute value side, it's not going to become positive on the linear side of it, okay? So that's what's happening with that one. This example right here, same kind of thing is going to happen, because you have a linear equation and you have an absolute value equation, and linear equations can intersect 2 times, but in this one, it's not going to intersect 2 times with an absolute value equation. So I'm going to say 3m minus 4 equals m minus 2, and I can add 4 to the other side, and I can also minus m to this side. So I have 2m equals 2. So when I divide, I'm going to get 1. So what happens is, with this one, 3 times 1 minus 4, this is me plugging it back in, equals 1 minus 2, the absolute value of 1 minus 2. Well, 3 times 1 is 3, 3 minus 4 is negative 1, and this says negative 1 equals the absolute value of negative 1, but the absolute value of negative 1 is 1, so it's saying negative 1 equals 1. That doesn't work. So this one right here is called an extraneous solution. And so that's an important vocabulary term to remember. I don't think I mentioned that on this one. This one right here would be extraneous because when we plugged it back in, it didn't work. So I'm going to label this one as an extraneous solution. It's just another way of saying it's an extra solution. Mathematically, it's there, but really it's not. I don't know. That's pretty much how I can sum it up. So let's do this problem for when one side is negative. So 3m minus 4 equals, and then I'll say like negative m minus 2. And I'll make it in parentheses because it's to the entire side. So distributing that negative means I'll have negative m plus 2. And again, it really doesn't matter what side you choose to make negative. I just had to pick one side. So I can add m, and then I can also add 4. So I'll cancel one thing on the left side, I'll cancel one thing on the right side. I have 4m equals 6, which means I can divide by 4, and I get m equals 3 over 2. So that one's going to work, because surely they both wouldn't not work, right? But let me show you the graph. Okay, so here's the graph. You see they clearly intersect just one time, and that's at 1.5. Well, 3 divided by 2 is 1.5. So if you want, you could also write that for that one. See there, I'll just circle it all the way around now. So yeah, that pretty much wraps it up. So you gotta keep an eye out for those extraneous solutions. You can always plug it back in to see if it'll work, or you can graph it as well. I could go back and I could plug this one back in and it would actually work. 3 times 1.5 is 4.5. 4.5 minus 4 is 0.5. And this one would say 1.5 minus 2. Oh, I should look at the original, which means that's going to make negative 0.5. Absolute value of that is positive 0.5. So they would both say 0.5 equals 0.5, which is what the graph is showing. But yeah. So that's it. I hope this helped. Stay tuned for the next video. Bye, everyone.